Welcome to Unit 9, Lecture 4, the final lecture of this unit on the atmosphere, and this lecture happens to be on air pollution. So stuff in the air that makes the atmosphere less useful to us or could even end up causing problems. I'm going to start off by talking about what causes air pollution and exactly what air pollution is. And air pollution is the contamination of the atmosphere. And it can be from wastes from both sources like industrial burning and automobile exhaust. Air pollution can be solid, liquid, or gaseous. And while most air pollution is a result of human activities, some air pollution is natural, such as dust, pollen from trees and other plants, spores from fungi, and then stuff like sulfur dioxide, which comes out of volcanic eruptions and gets in the air and then could end up eventually contributing to acid rain. So while a lot of air pollution has to do with human activities, there are some natural processes that also pollute the air and have been doing so for millions of years. Now, when we look at air pollution, we separate the pollutants into two categories: primary pollutants and secondary pollutants. And primary pollutants get put there directly by a human or natural activity. Alright, soot from smoke goes up into the air, and that's the direct result of burning something. That is a primary pollutant. A secondary pollutant forms in the atmosphere by chemical reactions with a primary pollutant. Alright, an example would be ground level ozone. So ozone, as we found out earlier, is a very important part of the atmosphere up in that upper stratosphere. It helps protect the Earth from UV radiation and does some really good things. However, if ozone is at ground level, we call it smog. And ground level ozone happens when UV rays from the sun mix with the emission from cars and oxygen in the lower atmosphere, and then we get ground level ozone, which is not too good for us because of the way it reacts with our bodies. Right here is a beautiful table showing the primary pollutants, and they're broken down by their major sources. So we have electricity production. As you can see, electricity production produces mainly sulfur dioxide or sulfur oxides and nitrogen oxide, and that's because a lot of our energy production comes from burning fossil fuels, and there are a lot of nitrogen and sulfur compounds in those fossil fuels. Industry leads to a lot of volatile organic compounds called VOCs. We'll talk more about those later. And a moderate amount of carbon monoxide, which is a colorless, odorless gas that restricts our body's ability to take in oxygen. Transportation, such as cars and airplanes that use fuels, put the majority of the carbon monoxide in the atmosphere, and that is by far the worst thing they put in the atmosphere. But also throw in some nitrogen dioxides and some volatile organic compounds, and then other sources not part of electricity production, industry, or transportation provide even more carbon monoxide and some particulate matter. And other sources would be like fires and stuff like that, which could provide soot and other primary pollutants in that way. Household products, motor vehicles, and power plants are all sources of primary pollutants. Specifically, as we saw that last one, carbon monoxide's a big one, and then there were the nitrogen and sulfur oxides, and then volatile organic compounds. Alright, the main sources of nitrogen oxide are vehicles and coal-burning power plants, which are used to create power. And then power plants in industry, such as refineries, metal smelters, put in the most amount of sulfur dioxide emissions, which are all primary pollutants. Now, the problem with the nitrogen oxides and the sulfur dioxides is that they end up reacting with water vapor in the atmosphere to form nitric and sulfuric acid, respectively, and because of their forming those acids, we end up with acid precipitation. Gas station and vehicles themselves make up most of the volatile organic compound emissions, the VOC. And then as we go to those particulate matter, we divide those into coarse and fine particles, and those come from vehicles, coal-burning power plants, and also cement plants, mining operations, incinerators, and wood-burning fireplaces, fields, roads, all this stuff that can put larger chunks of material up in there that don't get classified as nitrogen oxide, carbon monoxide, or sulfur dioxide, or VOC. It's a different class that involves a ton of different chemicals, but they're put there mostly, like I said, from burning stuff and from mining. You blow something up with some dynamite, you're throwing some dust into the air that shouldn't have been there. And that's a type of primary pollutant. Air pollution, while a lot of people would think that it really came to the forefront with the invention of the automobile in the early 1900s, it's not the case. We've been trying to figure out this problem of polluting the air for hundreds, if not thousands, of years. We know that in 1273, King Edward I in England banned sea coal, which was a very dirty type of coal that put up a lot of black smoke, put a lot of problems in the air that were not there before. However, we have seen an increase in the problem or a decrease in the health of the air, mainly due to the amount of fossil fuels being produced. And we see a lot of air pollution around urban areas where there's lots of industry and lots of vehicles, which are two main causes of most air pollutants. Because of these motor vehicle emissions and because of the pollution from cars and trucks and all that stuff, we have developed different laws and bills to help kind of bring that in check. All right. According to our U.S. Department of Transportation, in the U.S. alone, people drove vehicles over 3 trillion miles. In 2010. This is 3 trillion right here, just to give you an idea of how big that is. Most of this mileage is driven by passenger cars and light-duty vehicles, right? Not by those semi-trucks or buses, but by mostly vehicles that people use for everyday use. In order to help try to clean up the air and regulate these vehicle emissions, the U.S. passed the Clean Air Act in 1970, kind of fixed it up and updated it in 1990. And what this act did is it gave the EPA, Environmental Protection Agency, authority to regulate vehicle emissions. All right, and what the EPA has done is they've eliminated lead in gasoline, which has really decreased the lead pollution. So if you remember back When we did Age of the Earth, we watched an episode of Cosmos, and it talked about the guy who discovered the age of the Earth and how he also, at the same time, discovered lead polluting everything. All right. Well, this all happened after that, so that we're talking last 50 years or less that we got to all this. All right. The EPA also required catalytic converters in automobiles, which tries to clean gas exhaust before they're able to exit the tailpipe. Now, they don't do a perfect, but take out some of the harmful chemicals. Industry is another leading source of air pollution. All right, and the main industry that does this develop electricity, and to get electricity we have to burn fuel. Usually we're burning coal or some other type of fossil fuel. Yes, we have some nuclear reactors, we have some hydropower, wind power, solar power, power plants as well, but the majority of our electricity in this country and around the world still comes from burning fossil fuels. And what happens is when we burn fossil fuels, we get lots of sulfur dioxide and nitrogen oxides up into the air. And power plants alone give off 2/3 of the sulfur dioxide and more than 1/3 of the nitrogen oxides that pollute the air. And these all lead to acid rain and acid precipitation as they interact with water, which is found up in the atmosphere. Other industries produce these volatile organic compounds, which are just big chemical compounds. Also, people also call them toxic fumes. All right, you can see these in places such as dry cleaners, oil refineries, all right, furniture refinishers. All of this stuff pumps these toxic fumes into the air. Kind of industry where you need to wear a gas mask while you're working with the stuff is probably polluting the air with some sort of VOC. All right, and then on top of VOCs being produced while products are made, some of the VOCs get added to the air when people use the products as well. So it's like the double whammy right there with putting these volatile organic compounds into the air. The Clean Air Act also sought to limit the amount of sulfur dioxides, nitrogen oxides, and VOCs that were in the air, usually by making industries use scrubbers or some kind of other pollution control device. What a scrubber scrubber removes harmful pollutants, harmful substance that would pollute the air. All right, it's a machine. It takes gases, it sprays those gases with water, and water will dissolve many of the pollutants. Ammonia is a gas that will readily dissolve in water, and so by spraying air with ammonia in it with water, or making that air pass through some water, you take out a lot of the ammonia. That's one less pollutant entering the atmosphere. Other machines are called electrostatic precipitators. Alright, what they do is, well, as you can see, electrostatic. You've heard of static electricity. Well, they kind of use that idea. They take gas containing the dust of cement or leftover coal particulates in smokestacks, and then try to remove that dust by sending it through an electrically charged static cell. And what happens is an electric charge gets transferred to the dust particles. The dust particles stick together based on static electricity and to the sides of the chamber, and then they are removed from the air because they're stuck to the sides of the chamber instead. All right, and all of this comes from the idea of the Clean Air Act and are trying to regulate air pollution. Now, we're just one country. Our rules don't apply to everybody, so other countries might have more lax rules and are putting more pollution in the air. But we can only kind of deal with our own right now. So what we've got coming in is we got some dirty gas coming into our scrubber right here. Over here, water comes in through this filter area, and that dirty gas goes through the water, gets sprayed with the water, travels through the water, becomes a wet gas, which then goes through a filter, and that filter collects a lot of the particles that dissolved in the water. Dirty water goes down to be purified. The wet gas goes up through this filter, and other harmful chemicals are taken out by the filter, and then the clean gas gets released to the air. Alright, these electrostatic precipitators and other types of scrubbers can take a lot of ash and other chemicals out of the air, and then we can collect them and remove them and do with them what we will. Smog is a big problem, especially in large cities. Alright, it is urban air pollution. And it's a mixture of smoke and fog, which is where the word smog comes from. SM for smoke, OG for fog. Put it together, you get smog. And really what ends up happening, you see it best in this picture here, is we got automobile exhaust, which contains some different chemicals in it. Carbon monoxide and sulfur dioxides and nitrogen oxides. And it reacts, that automobile exhaust reacts with the UV radiation and the oxygen in the air to make some ozone, down lower level troposphere ozone close to the earth, which then reacts and makes smog. Alright, so it's an interaction between sunlight, air, car exhaust, and ozone. Now, where smog gets really bad is if something called a temperature inversion happens. Now, normally warm air rises above cold air. However, sometimes warm air can get above the cooler air. The cooler air, and what happens is the warmer air above keeps the cooler air at the surface. It can't move upward like it normally would, and the pollutants get trapped. Typically happens in cities located in a valley. Alright, LA is really famous for its temperature inversions and its smog problems, air pollution problems. Because what happens is 3 sides of LA is surrounded by mountains. Alright, and the other side is in a valley. And so you get this chance of this temperature inversion happening over the city of Los Angeles all the time. Right type of wind. Same thing happens in Phoenix, which again is in a valley surrounded by some mountains. The air just kind of sits there, it doesn't get to move until the wind blows from the right directions and pushes the polluted air out. So normally you have warm air on the bottom, cool air up here, the warm air goes and it leaves. Well, if that cool air ends up below the warm air, the trapped pollutants and smog get stuck at the top, at this layer of warm air. They can't move through it anymore. And so this pollution just gets trapped right there, and we gotta wait until something causes this cold air to get back here to get through this warm air inversion. And when you have all these trapped pollutants here, that's when you end up with heavy air pollution problems, smog problems, and from weather services and everything to not go outside or cover up your mouth when you go outside. You can see these if you watch the Weather Channel especially during the hot summer months. These tend to happen a lot in cities like Phoenix and Los Angeles. So that is your lecture on air pollution. where it comes from, the types of pollutants. If you have any questions, bring them in class, and have a good night.